Hello and welcome back to PANCast. In today's episode, we will discuss runtime protection, and we have a special guest. Now, Akshay, as you are joining us for the first time on PANCast, could you start by telling us a bit more about yourself?
Hello, John. Firstly, thank you for having me on this PANCast today. I am Akshay Rastogi, and I am a staff technical support engineer in the Prisma Cloud Compute team with years of experience with cyber and network security.
Thanks, Akshay. Now, the topic for today is runtime protection. Can you tell us what runtime protection is and why we need it?
So, runtime protection is one of the features of Prisma Cloud Workload Protection Platform, which involves monitoring and protecting workloads as they run in the cloud computing environment, defending them against attacks and unauthorized activities in real time. It uses techniques like behavioral analysis, machine learning, and signature-based detection. It integrates with threat intelligence feeds for up-to-date threat detection.
What do you mean by workloads?
By workload, I mean databases, applications, batch jobs, user requests, which might be hosted on various platforms or resources such as AWS EC2 instances, Microsoft Azure's VMs, Google Cloud's containerized applications, or serverless functions. And each of these workloads present a potential attack vector for threat actors. So every workload that performs a service, regardless of how briefly it's operational, could be targeted for attack. This is where runtime protection comes in.
Can you give us some details on how runtime protection works?
Well, runtime protection works independently for all these type of resources. Though you would notice that the feature sets like file system, process, and network protection are more or less same for these resources. However, the way the data is processed varies. For container resources, runtime creates something called a container model for each image, which is a unique one-to-one relationship between models and images. It does so by using machine learning and behavioral analysis that are static and dynamic in nature. For other resources like host, app embedded, and serverless, it does not create any model and instead directly monitors the workload behavior and take action as per the configuration. Runtime does create an observation deck for host and app embedded, which one can find under monitor runtime. This may help admin understand the workloads and therefore configure their respective runtime policy rules.
Okay, so how will this help the admins to protect their workloads?
There are feature sets as mentioned earlier, such as file system, process, and network protection available for different resource types and are designed to keep in mind the behavior of these resources. For example, the resource will have running processes. It will be making connections in and out of its environment. It will try to perform different file systems related operations, and these could be malicious. Admin will have information about all these operations and can decide what action it wants to take, such as allow, prevent, block, or just want to generate alerts.
Now we understand what runtime protection does, so how can one take advantage of this?
So the runtime protection feature is already simplified, as it is divided into different sections on the basis of type of resources, such as container, hosts, serverless functions, or app embedded. Each section controls the activities of its respective workloads. That could be as per the manual configuration added by the admin or by the model created by the Prisma Cloud runtime engine. For example, if an admin wants to create a runtime container policy, then the admin should first understand what Prisma Cloud has learned about the containers by looking at the container model, and then configure the runtime rules for the container policy. For each model entry, admin will find one of the model status such as active, learning, relearning, or archived. You can find the details of these status in the Prisma Cloud admin guide. Admin can open the container model for each specific entry, then look at the tabs to understand what has been learned for different feature sets. So let's understand this with an example. If the container is running a BusyBox app or CMD bin bash as a part of the image, then that will be added in the static analysis when the container is loaded for the first time. Now, if a user runs another process manually, or it is a sub-process of a process user executed, then that will be recorded in dynamic analysis. Good example of this is performing an apt get update. You will see so many processes file system changes being recorded as apt get will try to make those changes during installation and update. All these learned details works as an allow list. Then you can configure rules to tweak this behavior. So a simple concept to remember here is container model plus minus configured rules equals to allowed behavior. Similarly, for host and app embedded, admin can look at their respective observation to find the details such as app names and their startup processes, then accordingly configure runtime policy rules.
What are the different use cases where runtime policy provides protection?
Well, there is an extensive list of features for all these resource types. Let's try to understand a few. You can take actions such as alerts, prevent, and block. Prevent is when you do not want the execution to occur, and block is when you want to shut down the workload altogether. Let's take an example of process feature. Let's say you do not want the user to execute curl or wget. Then you can use a prevent effect which will throw an error when a user executes it. Similarly, block effect will terminate that container. Another example is if you want to generate an alert if any crypto miner process is executed or a crypto miner socket is initiated, then select alert effect. Or if you want to terminate a container when a process such as netcat is executed, which can be used for lateral movement attacks as well, then use block effect. Please note, there might be some processes that might not trigger any prevent action. It might be due to the fact that those processes are very short-lived, like ls and pwd. Similar to processes, we have networking, which monitors network activity from the containers. Then we have DNS monitoring, which analyzes DNS lookup from running containers. You can explicitly allow or deny domains as well. Then we have file systems, which monitors and protects from any changes in the files which are not a part of learned model, like changes in SSH configuration or certificates, and many more. It can detect the presence of malware too. For malware, it uses the intelligence stream to compare the MD5 of the files with MD5 databases of malicious files. Even if all these rules and models don't capture all your scenarios, then you have custom rules. Custom rules help you take a specific action by analyzing behavior using expression grammars. For example, you want to alert if a process named P1 is trying to be executed, or if the process command line has P1 in it, then you can write a rule and add an alert effect to it. Similarly, there are variables that one can use in the message field, and this will be added in the message section for your audit events. This is just an example of a process event. We have different set of attributes for file systems and networking events too. You will find all these different examples in the admin guide. While configuring these custom rules, make sure that these rules don't overlap with other feature set rules as the custom rule takes preference. Also, the custom rules don't take preference in case of crypto miners, as crypto miner detection is dynamic. Runtime engine follows some set of checks like resource utilization, command and control connections, along with MD5 to detect a process file as a crypto miner. Please note, these are just a few examples of what these features provide.
Great. Now we've created rules, how can we monitor these activities and troubleshoot if something doesn't work as expected?
Sure, we do have many dashboards which can help you find the incidents and provide great details on what has been executed and in what category that incident falls. Let's discuss a few of them. There are individual monitoring tabs for these resources under Monitor Runtime. This is a section where you will find a container model, host, and app embedded observation. You will get information about what is learned about the containers, like processes executed during learning hours, connection initiated to ports and IPs, changes made to the file systems, and so on. Then you have Incident Explorer. This single incident dashboard will show you the incident details, what was impacted, and you can see different stages on the workload using forensics, and it will show you the radar view as well for all the connection to and from the workload. Then you have runtime audits under monitor events. It will have audit data which includes message of the event, effect, event type, user, and the rule through which it is generated. Last but not the least, the defender logs. This gives you the similar details as the event with few extra details like when the rules were pushed onto the defenders. I would request you to listen to our interesting PANCast, The Importance of Making Use of Defender Logs, to learn more.
Great info, Akshay. So, what are the key takeaways for today?
So, use runtime protection whenever you would like to detect and protect action executed on running workloads. Always look for container models or host and app embedded observations to understand what is learned and observed about the workloads. Make use of custom rules if machine learning hasn't picked up the required use case. Last but not the least, troubleshoot and detect activities by using individual monitoring tabs, event audits, and defender logs.
Thank you again, Akshay. I hope our listeners have learned a thing or two about runtime protection. For our PANcasters out there, if you'd like the transcript of this episode, please head to live.paloaltonetworks.com.